Okay, let's go ahead and get started. And welcome to today's training. My name is Jeff Berger. I'll be your trainer today. And we're going to be going through the Honeywell HC900 hybrid controller. This is a controller that Honeywell came out with probably about 20 years ago or so. If they first came out with a product called UMC800, and then later grew into an HC900. So we're going to dive into a short PowerPoint here, going through some tech and spec on the HC900, going a little bit over into overview of the product, and then we'll move into showing you the display, navigate through some of the displays that we have on our demo unit that I have set up for the training today. And then we'll probably follow up with a quick tutorial on this programming software that's used for the HC900. So with that, let's go ahead and get started here into the PowerPoint real quick. So today's agenda, we'll do an overview of the HC900. We'll dive into the hardware specifications, review the software, some vertical markets that the HC900 plays very well in, and then some specific applications in regards to boilers, fuel-air ratio, and a couple other applications. We'll also wrap up at the end of the training today with a question and answer session. So we'll stick around afterwards and we'll go through that. Today's session will run a little bit longer than our typical 30-minute session that we've been having. Probably be about 45 minutes to an hour, somewhere in there. But we'll try to keep in mind your time and your schedule so that we minimize the time away from work there. So when we talk about the HC900, the HC900 is actually part of a family of products called ControlEdge. So the ControlEdge family includes the HC900 process controller as well as a SIL2 safety controller. These can be used in a redundant fashion or non-redundant. The two processor racks that I show here on this slide at the very top are for redundant applications. So you have two power supplies, two CPUs, and then a switchover unit in between them. At the very bottom of the display, you have the ControlEdge PLC. So the ControlEdge family does include a PLC for those type of logic controls where you just need discrete control of a process. Most times this is replacing either an Allen Bradley, a Siemens PLC, Modicon, GE, several other PLCs out in the industry, but spec for spec, the ControlEdge PLC matches up with all of those other brands out there. The ControlEdge RTU, which is in the lower middle, this is for applications where you might need a remote termination unit out in the field to accept inputs and provide outputs to a process like a pump house. It could be a remote pumping station, a remote skid gas train. A lot of different applications where you just need an I/O rack out at the process to be able to do some of your process control. It really allows for quick and easy addition to I/O out in the plant where you might have hard to reach areas where you don't want to add a full PLC or a hybrid control at one of those processes. In the lower right-hand side, we have the ControlEdge UOC. This is for applications where customers might typically have a large DCS Honeywell system like an Experion PKS or an Experion LX, where you want to add a simple process PLC type rack out into the plant and allow that to live and breathe in the same environment as an Experion programming system. It shares all the same points. It migrates very easily when you're adding points that you add them in the same environment as the Experion PKS system. So this is for the larger DCS systems, typically oil refineries, petrochem, maybe even typically pharmaceuticals, and those type of applications. So this summarizes the Control Edge family and consists of several different products. The HC900, as stated in that last slide, you can use it for process or safety or a combination of both. The HC900 is SIL 2 rated for safety applications, so you can typically use this in applications such as burner management systems where you want to do the burner management in the HC900 and provide that functionality as far as startup and shutdown sequences for the burner system. You can also use it in environmental safety type applications or spill prevention. Anything that requires a higher level of safety in SIL 2 rating, the HC900 has a processor that's capable of doing that. The nice thing about the HC900 safety processor is you could also use it for process control as well. So if you did have an application that had both, you can use the same processor for both applications. Or if you had a situation where you needed to separate that, you can have a dedicated rack for process and a dedicated rack with its individual CPU for safety. We've used the HC900, safety HC900, for a lot of burner management type systems. Two ways that we typically do that is, one, we either tie the HC900 with the communication output to a RM7800 series, which manages the burner safety, or we've done applications on large boilers, large utility boilers, where we actually have implemented the burner management directly into the HC in the SIL 2 processor, and then we've used the industrial flame monitoring sensors for UV and IR detection, providing a signal back into the HC900 rack. So as I said, you can use, you can separate out the systems. You can have a safety system and then a process control system. You can separate them this way. In this scenario right here, both of the systems are communicating up to the same Ethernet link, which is tied into a DCS system like an Experion Honeywell system, or as well a dedicated operator interface that we're going to go through in a little bit, that has a lot of pre-built displays that you can communicate to the HC900 and interact with the process. The other scenario that we described is you can have both safety and non-safety CPUs on the same system. So in this application here, we have a redundant CPU network at the top, and then along through the bottom here we have safety I/O and non-safety I/O, which minimizes some of the stocking that some of these plants have to do as well. If they have to carry safety spares and non-safety spares, this kind of helps reduce some of that inventory that they have to carry. So when we take a look at the hardware architecture of a HC900, let's go through this real quick to describe a little bit about what's in the rack and some of the options. At the very left-hand side of the rack, we have the power supply. This can come in 24 volts, 120 volts, 220 volt. Those are different options there for the power supply. This does not take up an available slot in the rack. So slot 1 starts with the very first I/O module. It does not start with the power supply. So the first would be your power supply. The next is your CPU or controller module. There's actually 4 different variations of the CPU module. We have a C30, a C50, a C70, and a C75R for redundancy. There is at the very top, there is a slot here for battery. That battery has a backup battery in it as well. This is something here that holds some of the non-volatile memory with the real-time clock and things like that. Down through the middle of the CPU, you have two RS-45-232 ports. This can be used for a number of different things. One of the main things it's used for is communicating to third-party devices out on the plant floor that might have Modbus communications. So you could actually tie in UDC controllers, Honeywell Herculine actuators. You can tie in paperless video recorders if you wanted to, but there's a lot of different options that serves up as part of the functionality of the HC900. It's very versatile, and like I said, it is a 3-wire RS-45 half duplex, but it gives you the 2 ports there. Depending on the version of the CPU, you'll get 1 or up to 3 different Ethernet ports. Then a C30, you'll get the 1 Ethernet port. This is dedicated for an operator interface if you want that as an option, which is displayed over here on the right-hand side of the PowerPoint. The middle one here is another Ethernet network port, and you can take that out to a DCS system if you wanted to, like a SCADA, like Experion or SpecView, or some other SCADA system that will be hooked up to the network on a computer, either in the engineering lab or in a operating room or whatever it might be. Wherever they have that PC where they want the interface to look into the system or into the process, they can have that hooked up to the E2 port. The last port here is I/O. This is for additional I/O. So you can have additional HC900 racks hooked up to the single CPU, and the system can actually grow with the process. So if you get into an application, let's say for example you have one boiler that you want to control this with, but later on the plant adds additional boilers or additional control loops that they want to control and monitor. As your I/O grows, you can actually hook on additional racks through this port and have those out in the field. To the right of the CPU, we have our first slot, slot 1. In the HC900 world, we have several different size CPU racks or I/O racks. We have a 4-slot, an 8-slot, and a 12-slot chassis. So again, based on how many I/O you'll need, you'll choose the rack to accommodate the amount of I/O. We have several different flavors of different inputs and output boards. We have analog input boards, which are universal, which means on the same board you can have a thermocouple, an RTD, 4 to 20, 1 to 5 volt, all on the same board and configured for your application. That's pretty unique in the industry. Typically in the PLC world, you'll be ordering a board for specific analog inputs. In this controller, it's universal. Honeywell kind of kept that same theme, when they came out with the UDC controllers, universal digital controller, that allowed for universal analog inputs, and they carried that forward into the HC900. You can also select several different output boards, one being an analog output board, which provides 4 to 20 milliamp output for your control loop, as well as digital out, which can be either relay, 120 volt, 24 volt, and digital inputs with either digital input contact, the 120, 24 volt. So you can get different options there for your input and output cards based on your process. The nice thing about this product when they first came out with it, like I said, 20 some years ago, is Honeywell knew that they were always pretty good at process control as far as PID control. I mean, if you go all the way back to 30, 40, 50 years ago when they first came out with the home thermostats, Honeywell was always known for that temperature control or comfort type control, and they were always pretty good at it. So when they came out with the UDCs, the digital auto tuning, the fuzzy logic, the programming methodology, what they did is when they came out with a multi-loop controller like the HC, they embedded a lot of that same principles, functionality, algorithms into this processor, and then just converted it into a multi-loop controller versus the UDC single loop control. So as we move through this product, I want you to think of it in that fashion where if you have an application where you have 3 or more control loops, UDC controls, this might be a good, a good substitution for that, giving your customer or giving the plant or the operators a little bit more access into visibility into the process with troubleshooting, diagnostics, alarms, screens with graphics, things of that nature. The operator interface on the right-hand side, this is optional. You don't need the operator interface in order to run this, this controller. There are situations where you might have an air house unit or some other process that does not need this operator interface with the graphics. Most cases, customers will put this on as an option, just to give you a little bit more view into some of the pre-configured displays and things like that. There are 2 options for this display as of right now. You have a 10-inch display and a 15-inch display. There are both touch panel, touch screens with pre-configured screens in there to allow you to get the process up and running and reduce some engineering time that would be spent on a display that you have to basically build your own. So there is a lot of out-of-the-box features that I'll go through on the display today, but this is an option, and this would be connected up to your E1 port here with a simple Ethernet connection from the operator interface into the CPU. One of the other I/O modules that is a big differentiator for you and will help save some cost and spare parts out on the plant floor is a enhanced universal I/O module where you can have program for analog in and analog out on one board. It does come out 16 channels, 1 millisecond scan, which is very fast out in the industry. And then you can do things like line monitoring feature where you can actually monitor the input and output and be able to have some advanced diagnostics to help you in troubleshooting the system if you need that. But this is a newer I/O module that had come out, Honeywell had come out with that, like I said, it really helps. If you have a typical system that might need like 8 slots on the HC900 to do the control, in the past you had to have separate analog ins and analog outs. Well, now you could probably shrink wrap that into a 4-slot chassis and do that with a universal I/O module instead. The other feature that it has built into the boards is onboard diagnostics. So there is a CPU on each one of these boards that allows you to have advanced features, advanced diagnostics that'll let you go down and troubleshoot that single point. One of the big things that we use quite often in the HC900 is the early detection of failure of thermocouples on the analog input board. So on the analog input board, it will actually send a pulse out onto the line and look for a feedback to signify if that thermocouple is ready to fail or if there's imminent failure on the horizon where you might need to go out and change that thermocouple before it shuts your process down. So early detection is a big thing. The other real big thing that it offers is a backfill, a history backfill. So let's say, for example, your SCADA system was to go down and come back up after 15 minutes or so. There is a backfill option where the HC900 will take that data that was missing from that point and actually backfill it into the trend data so that there's no missing data when you're trying to go back and look for that type of stuff. Fault tolerant Ethernet. So there is an option for fault tolerant Ethernet. The HC900 does have redundancy, as we talked about earlier. So if you have a system that's very critical, that needs to stay up and running, and you can't live with any downtime, these type of setups are probably perfect for those applications. We come across an application probably about a year ago where we installed an HC900 safety and non-safety HC900 in a redundant fashion on a steam vessel that was carrying limestone on the Great Lakes, and it was powering a steam boiler, or it was controlling a steam boiler, two of them on the ship, and in that fashion it was very critical that they not lose their process control, because if they did, if they were going under a drawbridge and the drawbridge was down and they lost their steering, they could run right into the bridge. So, you know, that's kind of an oddball one, but there are applications out there where if a customer cannot live with downtime and he needs to have his process up and running at all times, that they would probably be looking at a redundant system for the I/O, CPU, and the power supplies. There are two different supported networks, I/O topology for the HC900, the star topology and ring topology. So when you get into these type of applications and you start working with the IT groups within the plants, then you'd have to make sure that that they are aware that you can have either one of these is supported by the HC900. As we stated earlier, same safety I/O and process I/O for both the different applications, so less inventory that you have to carry on your shelf. Again, for those type of applications where you might need SIL 2 safety approval, the HC900 does have that, and it also gives you voting capability inside of the programming of the CPU in those type of applications. Software on the HC900, the HC900 is configured with a process control designer software, which is function block. There are other ControlEdge family processors that can do both function block and ladder. For the HC900, it is only function block. What Honeywell tried to do, or they did do a long time ago when they came out with this product, is they took a look at a lot of this typical applications out in the field, and they put together a set of library function blocks that can, out of the, very quickly with a drag and drop onto the screen, accommodates a lot of different applications where you don't have to create your own function blocks. For example, there are standard function blocks for dew point, relative humidity, position proportional control, if you still have some of those out there, carbon control for heat treat applications. You can actually create your own library as well. If you had like let's say you had a 3-element boiler control, and you had a series of 10 function blocks programmed together or connected together in the programming, you can save that whole function block sequence as part of your library. So later on, when you want to go back out and redevelop or add a process, you can select that single function block from your library, drag it onto the screen, and program the HC900, which really reduces a lot of startup and engineering time. So very simple tools. We're going to go through a live demonstration of programming a simple PID loop. But a lot of engineers out in the field have said that this engineering tool can save them about 10 to 15% of engineering time with a lot of the standard function blocks that are in this library. And it also does a really nice job at version control. So as you're doing your first control system and you're putting it into the plant, obviously throughout the years, you or the engineers will be in there adding some things, changing some things, And there is a version control which will keep track of those changes for you. On the memory side of the, as we're talking about function blocks, on the memory side of the different CPUs that you have, it does have a memory capacity for certain function blocks. So a C30, which is kind of the entry-level CPU, you have a function block capacity of 400. The C50, you can program up to 2,000 function blocks. The C70, C75 is 15,000 function blocks. So there are, we've done hundreds and hundreds of these at Loy Instrument as a system integrator, and I don't think we've ever touched the limit of 15,000. Even in that point, even at 2,000, that's quite a program. So just know that there's sufficient memory in each one of these CPUs, but kind of depending on the complexity of the project or the program, you might have to select a CPU to handle that complexity. The programming software also acts as a diagnostic or troubleshooting software. So in the programming, it does give you the capability to go into the blocks into a online mode and actually visually see on that block the inputs, the outputs, the live process variable, the set point values, even the discrete values that are going on with the process while the process is running. This is a very, very powerful tool because you get a combination of both troubleshooting and programming in the same tool, and it allows for a very nice troubleshooting tool if you needed to out in the field. It also allows you to do runtime mode editing, which means, let's say for example, I had a process that had 5 thermocouples in it, and I wanted to add a load thermocouple, or I wanted to add a stack temperature thermocouple, or something in those lines. What this allows you to do is, while you're running the process, add that function block to the process or to the programming, download it, and go to a hot start. The hot start allows your process to still stay running. It doesn't shut your process down at all, and allows you to add that function block or tag or whatever you might need to add to the programming. I would just say in these instances where you want to do online editing, keep it somewhat simple. I mean, if you're going to be adding 5 control loops or 10 control loops and a bunch of other things, then yeah, you might want to shut the process down for those applications. And the HC900 will actually give you a warning, and it'll tell you if you're allowed to do that edit online. But this is a big differentiator because most PLCs are going to require you to do a hot start when you do a program change, and that means, a cold start, which that means you have to shut down the processor, start the processor back up, and while you're doing that, obviously your process is shut down. The built-in feature that we were talking about on the PID functionality, this is a standard with the HC900 on all PID loops, offers you standard fuzzy logic and AccuTune, which are both available in the UDC product line as well. So here's where I was saying a lot of the functionality that Honeywell really refined in the single loop controllers, they took that functionality, embedded it into the HC900. So when I go into a block, like a PID block, and I double click on it in the programming language, this is the screen that I will get on the right-hand side. And all the tabs up along the top, when we dive into this PID block and I show you the terminology that's used, if you know how to program a UDC, you'll know how to program these PID blocks in the HC900 because a lot of the terminology is used common between both of those platforms. This is just a description of fuzzy logic. Again, fuzzy logic, when we talked about it in the UDC world, this is something that operates separate from your PID, proportional band integral and derivative. but what it's there for is to minimize overshoot and undershoot of your process control at set point. So on the left-hand side is a PID with fuzzy logic. On the right-hand side might be stereotypical of a normal PID without fuzzy logic. Not all normal PID loops look like that, but if you have one that is looking like that when you do a trend, you might want to enable the fuzzy logic. Like I said, it's the same fuzzy logic that's used in the UDC, and they've embedded it into the CPU of the HC900. We talked a little bit about custom libraries. You know, a lot of our OEMs do use the custom libraries as well. This gives the OEM the capability to put together a control scheme and copy and paste that control scheme into doing multiple loops, or pasting it into a library where later on they can use that same custom configuration from a library that was already built and then drag and drop it onto the screen and use it for another application. So this greatly reduces a lot of the engineering time that's used on these applications. If you have systems that repeatedly use the same configuration, this would be a great option for you. One of the next features of the software, it allows you, after you are done programming your configuration for your application, you can actually do an export of the tag database and build a point database that can be later used and imported into a Honeywell SCADA system like PKS, Experion HS, Experion LX. It's also used for a lot of our building control systems where they're using similar SCADAs. Maybe the HC900 used on multiple airhouse units communicating to like an Experion EBI system, where this allows you to very, very quickly, without duplicating the points in your SCADA, to import the CSV file, and your point database is built for you within seconds. So let's talk, we're going to wrap up here with some markets and applications. These are some targeted vertical markets or vertical applications where the HC900 does really well at. This is not a full complement of applications, because believe me, in the hundreds and hundreds of UDC or HC900s that we've done at Loy Instrument, we've come across some pretty unique applications that are not included in this list. But that lends itself to how flexible the HC900 is and how you can adapt it to pretty much almost any application that has a closed loop process control system. But as we go through the left-hand side, a lot of the targeted vertical markets, mining and metals, so obviously heat treat applications, ovens, smelters, incinerators, process heaters, pharmaceutical markets, process controls, the refining industry. So there's a lot of applications where the refining plants will have a large DCS but want to implement a small batch system or a skid or something like that out in the plant. They can do that very quickly and easily with the HC900 tied into the DCS. Rails, HVAC, data center, commercial applications. Recently, we've started doing a lot of work with the Honeywell HBS division, Home and Buildings division, that does a lot of air makeup unit control on commercial facilities, large buildings where we're doing the process control for the air makeup units, and they're using the HC900 to do that. Data centers is another big one, and this is something that's come on strong within the last, I don't know, probably 5 to 10 years. You have all these huge data centers out in the middle of fields that you probably would never know they were a data center, but these centers house a lot of storage units, servers and stuff like that are accommodating Google, Amazon, a lot of other big online type companies where they have to store a lot of data in a central area. And the HC900 does very well at doing environmental humidity, temperature control, and things of that nature, and they've been using those on a lot of data centers. Pulp and paper, food and beverage, cement and glass, power, you name it, anything that has a process control loop, the HC900 can accommodate those very well. When we get down into some of the safety applications, like I talked about earlier, the burner management system, using an HC900 sill-rated burner management and a burner management system would be a pretty good example of a safety type system that you would want to use the HC900 in. Combustion control, pipeline monitoring, spill prevention, emergency shutdown. We're actually using the HC900 for not only process safety, but also for personal safety within plants as well. So there's one project that we just did where large heat treat facility that had nitrogen, H2S, HCl, O2 monitoring throughout the plant. And what we did was we used the HC900 controller as a safety controller, communicating to all of the LEL and gas detection sensors throughout the plant. And then if any one of those sensors was to go off because of an unsafe level, it sends a signal to the building management system. The building management system then takes the appropriate actions of, opening dampers, turning on blowers, things of that nature to evacuate that unsafe level in that particular area. So that's just one other way that you can use the HC900 in a safety application. As I was talking earlier, there are some standard function blocks right out of the box that you can use. This would be an example of a carbon potential function block that's used a lot in atmosphere enriched enrichment type applications in the heat treat industry. So this is used to control the enrichment gas and the dilution air into the furnace, and that affects your carbon control or your carbon potential that's in that heat treat furnace. So this control loop here would probably mimic like a UDC 3200 or 3500 that's using the carbon potential algorithm. And as you double click onto this block, you get an expanded area on the left-hand side where you can then configure that function block. Dew point control is another application where with using several function blocks, you can do carbon or dew point control. So you have a temperature probe, an oxygen probe input, going to a dew point calculation block, and then in return feeding a PID function block with an analog output. Set point programmer block. This is another huge benefit in the HC900 is that if you drag and drop this block onto the programming page, what that allows you to do is have a set point programmer which can ramp and soak temperatures or process variables over a specific time. So you can store up to 99 profiles into the set point programmer block where you then can name them and go back and choose a specific set point programmer that you want to run. These are typically used in batch applications. We use it a lot in the heat treat world, but you can use it on other applications as well. This pretty much mimics the DCP programmer line that Honeywell has. So if you have an application with a DCP 250, DCP 100, or the obsolete DCP 550 from Honeywell, you can actually use the HC900 in place of those with the set point programmer to accomplish the same functionality as those other Honeywell programmers. Let's talk about one in particular application where the HC900 really shines. Excuse me. This is a boiler control. So when you look at a boiler, you have a lot of different control loops in there that the HC900 can accommodate very well. You have drum level, you might have combustion control. In that combustion control, you might have fuel-air ratio, which the HC900 does very well at. Feed water control, blowdown control, pressure control. You can go around this circle and pick out a lot of the different parts of the boiler, depending on the size of the boiler, where the HC900 can really shine with a single I/O rack, with a single display, and really take care of a lot of those applications. And some of the larger utilities, the old way of doing things was to have like a UDC 6000 or a Foxborough or a Taylor Instrument, and have several of those in a panel that would be controlling each one of those, and hardwired, feeding the end information back to each other so that you could do things like master boiler control and feed forward and things of that nature. In the HC900, you don't have to worry about all that. You can combine all of those control loops into one I/O rack and wire everything into that one I/O rack, which makes things a lot cleaner. So when we take a look at HC900 used for boilers, there are other products within the family that you can use that can complement boiler control. You can use a ControlEdge PLC that we talked about at the very beginning. Experian LX and HS are Honeywell SCADA systems that you can use as a SCADA device to be able to monitor the process and do your control from a PC. ControlEdge HC900, obviously SIL2 for the burner management system, and then a local operator interface that you can attach to the HC900 to be able to look into the process. When we're looking at the some of the pre-built or function blocks that you could tie together to accomplish different control loops, we talked about fuel air ratio with O2 trim, drum level control, feed water, excellent temperature control. You know, you can get pretty accurate temperature control, you know, plus or minus 0.5 degrees. Kind of depends on your final control elements and how well they're calibrated and able to do the control. But if everything is on point and you have really good final control devices as well, you can achieve pretty tight control. Boiler master, so you can set up boiler master in the HC900, and then the last one is blowdown. Some of the challenges that the HC900 addresses for boiler type applications, if you have changing steam demand, the HC900 can do a lot of predictive type control in the configuration to be able to adapt to the steam demand changes. It also helps reduce some of the fuel costs that are out there using the fuel air ratio. If you have varying boiler loads, the HC900, along with the fuzzy logic and some feed forward or cascaded control, you can really minimize some of the swings, the upwards and downward swings in the boiler loads. Boiler efficiency, environmental regulations, these are some of the other areas with the fuel air ratio that you can you know, cut off those challenges with those type of features in the HC900. Last couple slides here basically go through, this is an example of a 3-element control. So here's an example, it shows the field with the strong steam drum level, the feed water and stuff like that, along with the pre-configured or configured function block scheme that goes along with the 3-element drum control. Boiler master, submaster, again, here's a function block scheme tied together. You have your analog input for your main steam header. You have your plant master pressure control loop. So this is your UDC controller. And then you have your output going to boiler 1 submaster, boiler 2 submaster, and tied to fuel air ratio. Fuel air ratio control, again, we have our fuel flow, our air flow, square root in order to get our, if you don't have a smart transmitter, you know, the way that you extract flow is by using a square root extractor. So we have a square root math block tied to the analog input, going to a PID block, and then tied to our fuel air ratio output. So the last slide before we get into the operator interface and some of the programming real quick, Honeywell does have a full complement, obviously, of products that can be tied together with the HC900 to really put together a tight integrated control package where you can be assured that you're providing a single source solution for your customer or the process out in your plant where you have one source to go to help you with all these other items. So, you know, the HC900 on the top left-hand side obviously can be tied into the RM7800 with Modbus if you wanted to. So you can communicate 3-wire right from the display or a Modbus module on the top of the relay into the 232 or 45 port into the HC900. Smart transmitter, so obviously pressure, flow, level, whatever you're trying to sense. Honeywell has a full line of smart transmitters to accommodate you there. Right in the middle, this yellow sensor right here is the Honeywell Analytics sensor that I was talking about earlier, where we were monitoring O2 and some of the other LEL types applications where we want to use the HC900 as a personal safety or environmental safety type device. These sensors can be placed out on the plant floor and sense those different gases or O2 or CO or whatever it is, and bring that back into the HC900 with either a Modbus connection or a 4 to 20 milliamp. So that wraps up the presentation here on the HC900. What I'm going to do is I'm going to power up, I have my computer currently connected into a live HC900 I/O rack along with the display. And the nice thing about the display is that if you use if you have a network with a static IP address, then you can open up a standard web browser and browse without any special software, browse the displays in the HC900, and it allows you to a very nice remote connectivity into the process to see what's going on. So what we're going to do is we're going to look at a couple of the standard displays that are out of the box from the HC900, and I will go ahead and share with you. Let's see here. Okay, desktop. So I'm going to go ahead and power up HC900. So right now you should see a display pop up using a standard web browser on my desktop with the HC900 display on it. If you don't see it, please speak up. But this display on the web browser mimics exactly what the front of the HC900 display looks like. You'll see at the very bottom where it has the back, it has logs, diagnostics, alarms, it has an event window, and then it has the date and time with run in the bottom right hand side. This is a standard display that we use quite a bit because what it is kind of like the scoreboard. It doesn't matter what display you're navigating to, this will always be on the bottom of each one of the displays because we feel that the diagnostics and alarms are pretty critical in all applications. So it doesn't matter what display you're on, if you have a diagnostic or an alarm situation, these will be present and you'll be able to go to them very quickly and access those. What I'm going to do is I'm going to click on the diagnostic just as if we were pressing the button on the front of the display. And let's show you a little bit about these displays that are pre-built in the HC900. This allows you very, very quick diagnostic of the system to show you what's going on with not only the CPU, okay, so we have the communication diagnostics, but also shows you all the modules in the rack that we have that are programmed out in the field. Shows you the revision of the firmware in the HC900 and then the controller, the CPU type. So in this one we have a C50. Now, if you look over here on the right-hand side, on rack 1, which I only have one rack communicating to it right now, we have a module error. So if I click on the module error, what that does then is it takes me to the rack 1, and it tells me everything about that rack. It says, is the rack configured? Yep. How's my controller? It's good. The CPU is good. Memory status. Well, I got a low battery, but it's not hindering me at this point. But it is telling me that I have a low battery signal on my CPU. If I go down to I/O status, now you'll see that there's a module error. Well, if I want to see what module is giving me the error, then I can click on I/O module, and now it'll tell me in my 4-slot rack, which I have modules 1 through 4, it'll tell me what each one of those cards are as far as physically. I have an analog input on the 1st slot, I have an analog output on the 2nd, I have a digital input on the 3rd, and then I have a relay output on the 4th. On my analog input and my analog output, it's indicating I have bad channels. Typically, when it says this, it means that I do not have a thermocouple, or I might have a sensor that has failed open and on my analog input. And my analog output, since I don't have a 4 to 20 hooked up to a motor or something else out in the field, it's indicating an open channel. So if I did think that I had a bad card, if I went to module details, it will actually tell me on that 1st slot, here's the part number for that, and here's the revision level for that particular card. So if you wanted to, in your troubleshooting, to take one off the shelf or get one off our shelf, what you would do is you would look for this part number, 900A01-0102. You would then give that to us or take it to your crib, find that card, take it out. The other great thing about the HC900 is if you wanted to replace the analog input, you can loosen up the terminal cover on the front of the card with 2 screws, slide the terminal back with the wiring still attached to it, remove the old card, plug the new card in. You could do this under power if you wanted to. We usually suggest that you power down, but Honeywell did state, and they always state on all their analog inputs and all their boards, that you can do hot swap. So you can put that into the process, then clamp the wiring terminal back down to the front of that card, and you never have to remove any of the wiring. The wiring is still in place, and it's very, very quick. So the reason why I wanted to show you these couple screens here under the diagnostics is because these are all pre-formatted screens. We did not have to develop these. We did not have to engineer these. They're there for you, and it's just a matter of using them or not using them. So this is how tightly integrated the display is with the HC900 CPU, and it really allows for some nice troubleshooting screens to allow you to very easily and quickly figure out what's going on. The other screen here, which is the alarms, I'm going to click on that right now. This is another pre-formatted screen. What it'll tell you is when a certain point went into an alarm. It'll have the tag of that point, so it'll tell you exactly what it is. And I can click on alarm group, and now I can actually group alarms and acknowledge those based on the grouping. So if I had room temperature alarms, I can click on this, and now I can get a full grouping of all of the room temperature alarms that is under that group. And I can either acknowledge it as a group or I can acknowledge it as an individual. And now it's acknowledged, but it's still an alarm, so we still have the red bell ringing at the bottom. Those are a couple of the standard displays that are really, really good for troubleshooting. I will click on the menu button here because there is one other screen that I want to show you that is, again, a pre-formatted screen out of the box where you can access information. So again, if we click on controller, I can go to summary display. And maybe I want to look at, maybe I'm doing calibrations, or I'm starting up a new process, and I want to see a summary of all of my analog inputs that are coming into the HC900. I can click on this button, and that'll give me a full display here showing me rack 1, module 1, channel 1, the tag name associated with it, the description, the value. Okay, so this is the real-time value along with engineering units, and then it'll tell me if there's an error associated with it. It'll do this for all the analog inputs as I program them in the HC900. So as I program them, it just adds them to the list and allows you a very quick access. Again, this is a display that's out of the box. You don't need to build it. It's just there for your use. If I click on the home display, this will take me back to a home display that gives me access to many different displays here. We'll go through these real quick and then dive into the programming here for a couple minutes before we wrap up. In the HC900, it does allow you for graphics. So this is a graphic of a vacuum furnace in a heat treat facility. You can see we have a lot of set point programmer indications. We have digital status indications. And as we go through our process of ramping up and shutting down, each one of these valves will actually highlight green or red depending on what's going on with the process. So right now I do have a set point programmer loaded into this. I'm going to go ahead and hit start. And you actually will see now we're in the pump down sequence. So the pump down sequence, all of this area over here is now green. It's pumping down. And once it gets down to a pump down level, then we're going to start ramping our temperatures up. But as we wait for that, let's go ahead and move on to another display and show you some other displays that allow you some different visuals into the process. Under vacuum set point programmer, the vacuum furnace PID control, which would be VAC furnace 3, this would be an example of a front end of a UDC. So we have our process variable, which is our actual temperature. You can see that ramping up along with set point. We have a percent output. So if you remember, we talked about 0 to 100% output out of a UDC, or the high and low limit is actually -5 and 105%. But most cases we keep that 0 to 100. You have your auto manual button, and then your remote select set point button along with the bar graph. So this actually gives you all of the indications that you would typically have, except for the bar graphs, on the front face of a UDC. And we've added a couple more things on this display. We've added a profile trend display on the right-hand side, along with a set point programmer, which actually mimics a DCP programmer that you would typically have on the front of the panel running the process. If I clicked on home again, it would go back to this very start there. Vacuum programmer. This is a screen that if I was to develop this screen from scratch, it would take me a very, very long time. The reason being is that this screen was developed by Honeywell out of the box, where it not only tracks and trends the process variable, and then set point, but it also pre-plots the entire set point profile on the trend screen. So the pre-plot is what really takes a lot of engineering time if you were to do this from scratch, if anybody's programmed those before. But what this does, it allows the operator to not only see the set point and process variable tracking along this blue line, but it also allows them to see and make sure that the set point profile is the profile that they want to run before they hit the run button. And it gives them a nice complete picture of that profile to allow them to sign off on it and proceed with the process. We have other displays like vacuum trend or trending displays. These basically mimic your process recorder that you would have on the front of the panel. You can build in trend displays into the HC900, and then you can store those trend displays as a CSV file, or you can push those trend files out to a server location and have the HC900 not only be the process controller, but also the recorder built into one process system. We do have other graphics like boilers. So here's a typical graphic of a boiler. A lot of these widgets that you see on the display are chosen from a library of standard displays that you can build with the HC900 operator interface. You can impose a lot of the digital and analog signals out into the screen so you can see actual process data as you're doing your control. Boiler control loop. So this would be an example. If I had a system, let's say I had an oven, a heat treat oven, or an application that had several process control loops. Let's say I had an old panel that had 5 UDC controllers. What this allows you to do, this faceplate will allow you to place those UDC controllers into segments on the display so that you can see individual control loops all at the same time, what the process variable set point is and what the percent outputs are. This gives you a very nice overview window of what's going on with the process and allows quick access into what's going on. There are some other displays here. Again, they're pretty much duplicates of what I have up at the top, but we typically, when we engineer a system or if we work with a customer that's creating their own, we usually recommend that you develop some type of home display that gives the operator a common display to go to access different areas within the process. And this is just a real nice, easy way to do that. Again, as I'm showing you this display, all of these displays are accessed through the web page that's built into the operator interface, and there's no special software that's needed. You can lock these out, you can put password protection on them, but you know, in today's age where we're all trying to do things from a remote access point, this offers a great way for operators, plant managers, engineers to have a remote access into the process to see what's going on. We're going over a little bit here. What I'm going to do real quickly is I'm going to share with you the function block programming, and I'm going to build a real simple PID loop for you that would mimic a real standard UDC control loop and show you how easy it is. So at this point, I'm going to power up the software here. All right, so if I was creating a new program, I could come in here to new. I could choose my CPU. Maybe in this case, it'll be a C50. And I can choose actually what revision I want to program that CPU in. There are applications out there where you might have an older HC900 system where you might have version 4.2, 2.4, or one of these other ones where you're not ready to upgrade the CPU yet and you still want to program in that environment. So you can click on one of them, hit OK, and then you can start your programming. So as you can see, when I select that programmer or when I select that CPU, it comes up with some blank pages over here on the right-hand side. This is my palette blank pages that I use to create my configuration. You have up to like 20 pages wide, and I can have 20 tabs with 20 pages under each tab if I wanted to separate out my configuration. For right now, excuse me, we're just going to use the single page, and I'm going to show you how easy it is to program a PID loop. So if I was to start programming my PID loop, the very first thing that I want to choose is my analog input. We have to have some way to feed back the process variable signal into my control loop. So what do? I take an analog input, drag it out on the page, and now I have my analog input. Later in a couple minutes, we'll go back and configure this, but let's go ahead and complete the rest of our control loop for right now and get this done. So the next thing is I have an analog input, but now I need a controller. I need my UDC to control the process. So let's go ahead and choose a PID block, which mimics our UDC. We'll place that out on the paper. And then last but not least, we need some way to control the process. So we need an analog output. Let's go over here to I/O, and we'll look down to analog output. there's one. We'll take this. Now, if I'm not lining things up really good, I do have a capability to snap to a grid if I wanted to. And this is probably driving Ken Bradway crazy because they're not totally lined up really good, and he's real particular about programming. But for right now, we'll just work with what we have. Now that I have my analog input, my controller, and my analog output, the next thing I need to do is I need to soft wire these things together so that the CPU can understand that these blocks are connected to each other, and this is called soft wiring. If I take my output pin, if I double click on it, you see I have a hash mark that comes up. I can connect that to the input of my PID block. Now the next step is to take my output pin of my PID block and connect it to my analog output. Now I have a PID loop that I can go in and configure. On my analog input, if I double click on that block, I can tell it exactly the physical address on my I/O slot. So I'm going to choose rack 1, module 1, channel 1. I can set up like filtering if I have a noisy input. I can bias the input. I can set up my high and low range. Also, it's universal. So let's just say I have a thermocouple input, and wow, geez, look at all these different thermocouples. Nickel, nickel, moly, haven't used that one in a while. WW26. There's a lot of different ones on here. Let's choose a real typical one, which might be a type K. And if I hit OK, now I have a thermocouple input type K, and if I look at the very top of this, it'll tell me exactly where that's located on the rack. Rack 1, module 1, channel 1. Next is I got to program my PID loop. If I double click on it, a lot of these terminologies at the top will mimic a lot what you see in a UDC. So on the general tab, I have to give it a name. So let's say it's zone 1. If you remember in the UDC class, we talked about different algorithms, PIDA, PIDB, duplex. This is where you choose your algorithm. We talked about reverse and direct acting. Reverse is always for heating, direct is always for cooling. In this application, we have a reverse acting. Start and restart. This is how we want the UDC to start up. When power is applied, do we want to permit manual and auto mode? Yes. Do we want it to start up in manual or we want to start up in auto? This will give all the indications of how we want the controller to start up. Do we have a remote set point source? In this instance, no, but we could get a remote set point from another PID block or some other source if we wanted to. And we can have it be in engineering units or percent. Range limits, again, these are the same things you see in a UDC when you program it. You're asked for your PV high range, PV low range, how many decimal points, do I want degrees F or degrees C, what's your set point high and what's your set point low. Do you want the operator only to be able to change the set point to 2000 degrees versus 2400? Output limits, we'll set these to 0 and 100. Tuning. Tuning is the next tab. So in all UDCs, you get automatically 2 tuning sets. You can program additional tuning sets in an HC900, but out of the box, you get 2 tuning sets. I can choose proportional band or gain, reset or resets per minute or repeats per minute. Rate. You can choose, and then you go over and you program what each one of those are going to be based on how you're tuning the process. Now, besides doing this, if you didn't want to manually tune it, you could come over to AccuTune. You can enable or disable AccuTune, and with one button push, you can tune the process and get it very close, if not right on, where you need to be for your tuning. Last but not least is alarms. So as before, when we were programming the UDC, you can see that we also get 2 standard alarms with the PID block. We can set our PID, or we can set our alarm one maybe to 1000 degrees, and maybe I want it to be a PV high alarm. Click OK. On the left and the right are input pins and output pins. I don't need all these connected when I'm doing my programming, but if I did want to use one of these, for example, I did program a AL1. If I have a hollow core pin, that means it's a digital status. If I have a solid core, that means it's an analog status. So if I want to tie my alarm to a discrete output on the HC, I can click on discrete output, take my alarm 1 over to the discrete output, and now if I double click on it, I can tell exactly where that discrete output is connected into my I/O rack. Last but not least, analog output. So as an analog output, again, it's a hardwired output, so we have to tell it where it's going to be on the rack. And if we're okay with the 0 to 100% output being 4 to 20 milliamps, then we're good to go. We can hit OK. And again, on that hardwired block, it'll tell you exactly where that hardwire is located. That is a simple PID loop. I can actually take this, I can copy, and I can paste it. If I had a 5 zone, a 10 zone, or if I had a process with 100 PID loops, I could copy and paste that 100 times, and I would be done within, pretty much within minutes or seconds. So with that, I know I've run over today. My apologies. Ken Bradway did tell me I would run over today, but there's a lot of stuff to cover. We do offer a full class at Loy Instrument, either in Fort Wayne, Cleveland, or Indianapolis, and we do the same training as what you would receive in the Honeywell factory. So if you wanted to get more information on that, you can contact myself or Roger Stevens. We can go ahead and get you that information. But that was a quick tutorial on the HC900, a little bit with the programming, a little bit with the display and the hardware and some typical applications. For those of you that are mechanical contractors or boiler contractors, this is a perfect product to be able to adapt to a boiler, depending on any size, if it's a large utility or a small package boiler, and provides a very, very good means of doing fuel air ratio control in it, as well as burner management. So with that, I will go ahead and conclude today's training, and I will go ahead and send a link out to all of you for the YouTube posting. And if you have any questions at any time, you have my contact information. You can give me a call and I can work through any specific questions you might have on the product, and we'll wrap up today's session. So thanks for everybody's time. Appreciate it, and we will be talking to you soon.